Hey, what's up? What's up? All right, so for real, what you doing?
None. Just chilling, watching the system.
Yeah, man. You see the windows popping up, all the apps running, got the music playing, the browser. That's just the party. You know what I'm saying? That's just the crowd on the dance floor. True, true. But the real power, the one that's actually running the door, checking the list, making sure everything's cool, that's the kernel. It's the absolute core of the whole Linux OS. It's the one running the entire show from the back office, for real. Okay, so what's this manager actually doing for real? Because it's not just standing there looking tough, right? Nah, the kernel's got some serious work to do. Let's dive into it. All right, so think about it like this. Every single program you run, even the little background tasks you don't see, we call that a process. And every last one of them, man, they got to get permission from the bouncer just to get inside the club. True story. No process does a single thing unless the kernel gives the okay. Exactly. And once they're inside, the bouncer's got to keep the party going, Keep that energy up, make sure everybody gets a turn out on the dance floor. And that dance floor, man, that's your CPU. And it can only handle like one main dancer at a time, really. So the kernel does this little dance. It's called a context switch. It's like it gives each process this tiny, tiny sliver of time, they call it a time slice, to just do its thing on the CPU. A quick moment in the spotlight, then bam, time's up. The kernel taps it on the shoulder, saves exactly where it was, and then points to the next process in line. It happens so unbelievably fast, you think everything's running at the same time. And this is the really key part. There's the super strict separation. So your apps, they're all hanging out in user mode. That's the main dance floor. They can have a good time, but they got to follow the rules. They got limited power. But the kernel operates in kernel mode. That's the manager's office in the back. It's got the keys to everything, full unrestricted access to the hardware. And that separation, man, that's what keeps one rowdy app from completely wrecking the whole party for everyone. That's it, exactly. And it doesn't stop there. The kernel is also in charge of all the club's real estate. We're talking the VIP booze and even the coat check. And that right there is all about your memory and your files. Yeah, so every single process gets its own chunk of your computer's memory. It's like its own private, totally soundproofed VIP booth. The kernel acts as the concierge, and it makes absolutely sure that no process can peek into or mess with another process's booth. That's what we call memory protection, and it's what keeps the whole party from turning into chaos. And what about the file system? Just picture a giant coat check, right? When you see a file name on your computer, that's really just the claim ticket. The actual stuff, the data itself, is what we call an inode. The inode is the coat hanging on the hook. It's the real deal, holding all the important info, like who owns it, who's allowed to wear it, and exactly which hook it's on. And check this out. This is a cool trick called a hard link. Look at inode number 15. The link count says 2. That means there's one coat, but 2 different claim tickets for it. So you can get to the exact same file from 2 different spots. And if you throw away one ticket, no big deal. The coat's still there because the count is still 1. The coat only gets thrown out when that link count hits 0. True. Right. You know how it is. A guest can't just waltz into the DJ booth and start messing with the records. You can't just hop behind the bar and start pouring drinks. You gotta go through the manager. Well, it's the exact same deal with your apps and the computer's hardware. The kernel is the only one they can talk to. So an app wants to make some noise, it has to ask the kernel to talk to the sound card. Wants to put something on the screen, gotta make a request to the kernel for the graphics card. It's always gotta go through the manager, making what's called a system call. The kernel is the only one with a direct line to the staff. So you might be wondering, why all these rules? Why so serious? All this management? Well, it's 'cause some guests, man, they ain't there to chill. Some guests just want to watch the whole club burn down. So what happens when you get some party crashers?
Yeah. In the tech world, that's what we call an exploit. They were always looking for a way to sneak past the bouncer.
Okay, so one of the oldest tricks in the book is the buffer overflow. Picture this. A programmer sets up a little 10-ounce cup in memory for some data. But then an attacker comes along and tries to pour in 15 ounces. Well, that extra 5 ounces has to go somewhere, right? It spills all over the place in memory. And if that attacker's real clever, they can make that spill overwrite the program's real instructions, basically changing the go home address to the go to my secret evil lair address. And if they get that spill just right, they're not a guest anymore. That party crasher can now run their own code using the app's permissions. And just like that, they can take over the whole show. That's why the kernel's job as a bouncer is so critical. All right, let's back it up for a second. How does this whole party even get started in the first place? You know, like, how does the club open for the night? Okay, so from the very second you hit that power button, there's a whole opening crew that gets to work. First, Post makes sure the lights and power are good. Then the promoter, that's the bootloader, like Grub, unlocks the main gate and finds the kernel. He hands the keys to the manager. The kernel takes those keys, wakes up the staff, and kicks off the very first process, usually something called init or systemd, and that gets the whole party started for the night. And we are on. So, you know, next time you're on your machine, just chilling, maybe watching a video, browsing the web, just remember the kernel. It's always there, in the background, totally out of sight, just running the entire show.
True. What's up?